All right, so welcome to the last unit. Unit 13 is called Thermochemistry. So thermochemistry is all about energy. So what is energy? Energy is a capacity to do work or transfer heat, okay? The total amount of energy will always remain the same. And we'll talk more about this later, but we cannot ever get rid of energy completely. It's only can be transferred, okay? Energy comes in two main forms. And the first one is called kinetic energy. And this is the energy due to an object's motion. So they're moving in some sort of way. So like kinetic energy, anytime you see anything, this bowling ball moving, the pins moving, you know it has kinetic energy. So motion of any kind, it has kinetic energy. Now there are specific types of kinetic energy, so we can like hone in on specific types. The first one is thermal energy. This has to do with heat. This is all about how active the atoms are. So basically, remember, if particles, like compounds and elements are moving, you know that tells us the temperature, right? So faster the movement, hotter the temperature, slower the movement, like low temperature, low energy that we have, right? So it's all about rapid or slow motion. Okay, the next type of energy is called electrical energy. Electrical energy is movement once again, but it's specifically about electrons. And so electrical energy is all about how we get electricity, right? Electricity is caused by movement of electrons. So when you see like a plug of some kind, there's electrons waiting to be connected so that it can move through and provide electricity and that type of energy. Okay, that's why we need power lines and things like that for electrons to go through to provide energy. The last type of specific energy that we're going to talk about is light energy. We talked about this last semester, but this is electromagnetic radiation. Electromagnetic radiation are your gamma, X-ray, ultraviolet, visible, infrared, microwave, and radio. This is called light energy. They all travel at the speed of light. They're moving, although we can't see it, right? We can only see color, but even then we're not actually seeing the movement of waves, but it is moving, and that's how we can see them, okay? And they're carrying energy with it. The other type of energy we can have is potential energy, and this is stored energy. It's mostly based on position, right? So exactly where they are. So two different types of potential energy is the first one's chemical. Chemical is basically when chemical bonds are created, they have energy stored within them. So chemical bonds are stored energy. So for chemical energy, you can think of like coal, batteries have stored energy. So once you make a connection, you can create that energy. Any type of food is chemical energy as well. So we eat that food so that chemical energy goes into our body so we can use it and transform it to other types of energy. So we consume chemical and then we can do other kinetic energies, right, to perform our tasks. Okay, the other type of potential energy here is gravitational. You talk a lot about this in physics next year, right? If you're taking physics, and it's all about its height and mass. So gravitational potential energy is all about how heavy they are. It has to do with gravity and how tall they are. So like this is all about, about like where they are, where are they going, right? Maximum potential energy, right? So you can see over here in scenario 6, that bigger elephant is going to have that greater potential energy because it's a lot bigger. It has a bigger mass. So all of this is into play here, right? So object C versus object B. So you can see the height difference tells you exactly what type, how much potential energy is there. All right. We're not going to talk too much about it now. It's really more about when you get to physics, we'll be doing these kinds of math problems. All right. So then to keep on going here, we are now going to talk about the law of conservation of energy. Energy cannot be created nor destroyed. Pretty sure this is supposed to be nor, but it can be transferred. So you can't just conjure up energy. You can't just get rid of energy, but they get transferred. Now it can be transferred into multiple different directions, but we cannot conjure up or completely get rid of energy. It changes from one form to another. So for example, here in your notes, you can see when you plug an electric fan into a power outlet, electrical energy is transformed into what type of energy? So the plug has electrical, it has electrons ready to move, and then the fan turns on. So electrical will turn into a very broad type of kinetic energy. It's an energy of motion of some kind, okay? And so does the total amount of energy change? Absolutely not. So the answer is no. It transfers from one to another. Another example is gasoline is burned to move your car. So what is gasoline then? So gasoline, you got to think about it's like stored energy. It's a chemical energy. It's burned to move our car, right? And then we're moving our car. So we're going from chemical in order to, and actually you can think of it, there's like a 3-step process. It's chemical, then to like thermal, that heat, and then it moves into kinetic energy. But ultimately, you're taking gasoline and you're moving your car, chemical to kinetic. Next one is when you turn in an electric lamp. Once again, it's electrical to light. There's a little bit of thermal sort of in there because light bulbs do get warm, but light is probably the bigger product there. Car battery is used to turn on headlights. You know, your battery has stored energy, so you know that's chemical. And then you see the light, so you know chemical is going to light. The last one is tomato plant uses a process of photosynthesis. Photosynthesis to turn into a tasty tomato. Oh, there's a typo. Faux salad. And so, how do you do photosynthesis? You need the sun. So the sun is light energy. It transforms into food. So that's chemical energy. And then you eat it for energy, right? Right? Sun is like the #1 source of energy, right, for us. All right. So then next here, what is thermochemistry? What is the actual definition of thermochemistry? Thermochemistry is the study of heat changes that occur during chemical reactions, okay? So remember that the temperature tells us how much motion, right? How much kinetic energy a particle has, right? So when we talk about heat, anytime we talk about heat, it is a type of thermal energy that transfers from one thing to another. So when you have something hot and cold, right, you have particles that are moving, right? So, you know, hot things move really, really fast and cold things move really, really slow. And so the hot temperature will always affect the colder temperature. The heat will transfer over, and then you will see a temperature change in both, right? So like heat always flows, so this is a huge thing here, from the warmer object to the cooler object, okay? You can't conjure up cold, right? Cool. If something's cold, then it's because heat is leaving, right? But if your house is really, really warm and outside is really, really cold and you open the front door and you leave it open, then the heat, because it's, you know, lots of moving particles, it's going to go towards the outside. It wants to go towards that energy change, and your house then is going to cool down because the heat is going out, right? It's always going to go towards the slower movement of particles, okay? Now, some of the stuff that we're going to talk about in the next video, but the 2 vocabulary words I really want to focus on is right here. Remember that heat, energy in general, can be absorbed or released. And the 2 vocabulary terms we're going to focus on is exothermic and endothermic, okay? If something is exothermic, energy is being released. Exo, think exit. It's exiting the system. It's leaving, okay? So heat is going to be considered negative, okay? Negative is just a quick way of saying like, hey, energy is gone. It has left, it's released, right? It's going. Endothermic then means energy is absorbed. It's coming into, right? Endothermic, into, or in, right? And so we are absorbing, we're taking in the heat. And so we usually indicate it numerically as like a positive number. So right now we're just sitting here trying to determine what's the difference between exo and endothermic. We're going to get to more about this bottom stuff in the next video, but let's look at some examples of endo and exothermic. You see these a lot in phase changes. So change of physical state is also called a phase change. So while it's changing phases, the temperature does not change. So that part's not really super important, but we're going to talk about how this affects endo and exothermic reactions. So melting. And the biggest thing is at this point, I want you to think about water. Water is very, very simple to think about. You know it, you're familiar with it. If ice melts, right, it's turning from a solid to a liquid. Okay, so we learned of this like at the very beginning in August. Now, freezing then is the opposite. It's going from liquid to solid. Now, you got to think about which one is endo and which one is exothermic because they're like opposites of each other. Remember, endo means heat comes into the water. So what, you got to think about if heat's coming into the water, am I melting or am I freezing? Okay. Or if heat is exiting, exothermic, right? Leaving the water, am I melting or freezing? So for melting, right? Why would something melt? Because heat went in or heat went out. Yeah, you melt because heat went in, right? So when heat comes into the ice, it starts to melt. Now, why does something freeze? Because it gets cold. Why did it get cold? Because heat went out. It exited, right? So freezing is exothermic. We say exo for short. So same thing with vaporizing and condensation. Why does something vaporize? We're going from liquid to gas. We're getting hotter and hotter and hotter. Condensation is then the opposite. It goes from gas to liquid because we are getting cooler and we're cooling down, right? So why? So you got to think about why is water becoming steam? Why is it becoming gas? Because it's getting hotter. Why is it getting hotter? Because heat is coming into the system. It's endothermic. So then condensation. Why does it condensate? Because we're cooling down. Why am I cooling down? Because heat is exiting, right? Exothermic, exiting the system here. Sublimation and deposition are, once again, opposites of each other. Why does something sublime? It's going from solid to gas. Why would something go from solid to gas? So that means it's heating up so fast, it basically skips the liquid phase. So if something's heating up super, super fast to gas, must be endothermic. It's absorbing energy. It's bringing it in, okay? Then deposition, right, is going from gas to solid. It's like it started out as a gas, but it cooled down so fast that all of a sudden it turned into solid. So where do you see that, right? Where do you see that in real life? You see that with snow or hail, right? The gas all of a sudden turns into a solid. And right now you saw that hail damage that we had. It's crazy hail. So why is it cooling down so much? Because it's exothermic. Heat is leaving the system. All right, so now we're going to do practice with all of that.